So let's start for today. Okay, so our topic today is linear systems and matrices. Linear system and matrices. So we in the last lecture we discussed about the linear systems, and then of course the matrices we did not talk about, but I think from your previous understanding you know that the matrix is a is an array of numbers, okay, and variables it can be. So I think you have a basic understanding of the matrices. So our two main topics in this today's lecture are is the Gauss elimination method for solving the system of linear equations, and the another method is the Gauss Jordan same method, elimination method. So both of these methods use the row operations. Okay, both of these methods use the row operations. And what are the row operations? There are three row operations. Okay, so first row operation is that you can interchange the rows. Interchange rows, okay, of the equation. So if, so for example, if you have three equations, so maybe you can change the first equation with the second equation. So first equation will come in place to the second equation will come in place of the first equation. So we can represent it like this, R1, R2, okay, so with an arrow on both sides. The second type of row operation is called as the can multiply by non-zero number. So any of the row, any of the equation can be multiplied by the non-zero number. Okay, non-zero number. So this type of operation can be also performed. So for example, if the non-zero number is say k, so and if you multiply row 2 by k, so this type of operation can be represented like this. K, row 2 will be multiplied by k and it becomes the new row 2. Okay, it will become the new row 2. And the third operation is perhaps the most important, is that can add a row or multiple people of row to another row. Okay, so for example, if we change, if we have second row, so we can multiply that second row by with some number, non-zero number, and then we can add that to the third row or the first row, whatever. So for example, in this case, if you multiply row 2 by k, okay, and then add it to row 3, and then it will change to row 3, and then it will be another row 3. So having all these row operations, we can transform an original system to an echelon form. So we have the original system, okay, of equations. So we can transform into, so we can write it like this in the transform. We can transform into echelon form. Okay, I think I forgot to mention about the echelon form last time. So in the echelon form, what is the echelon form? In echelon form, you have a system, something like this. So you will have a leading term, okay, and then there are some other terms in this equation. If you arrange the coefficients of the original system in the form of some rows and columns, so in the first row, okay, so you will have the different rows and different columns. So you will in the first row, you will have a leading term, which will be a non-zero number, okay, non-zero number. So that will be called as the leading term. And then in the second row, there will be a non-zero number as well, but that will not be at the same level. So for example, if the non-zero number in the first row will be in column 1, the non-zero number in the second row will be in column 2 or column 3, okay? And then there will be other terms. Or for example, in the third row, it cannot be in the third row, the non-zero term, the first non-zero term from the left, okay, the first non-zero term from the left, that is called as the leading term. First non-zero term from the left, now it will be in either column 3 or column 4, okay? So if it is not in column 3, then it may be in column 4, okay? But it cannot be in column 1. If it will be in column 1, then that will not be an echelon form, okay? And then echelon form also allows for the 0 rows and 0 columns, okay? So it will say that the echelon form will also say that if there are any 0 rows, and those 0 rows which will have all the elements in the column, that will be in the last row. So that is the echelon form, okay? Echelon or echelon, whatever way you want to call it, okay? Echelon form. So the purpose of the Gauss elimination method is to transform the original system into an echelon form, okay? Whereas the Gauss-Jordan elimination method, the purpose of the Gauss-Jordan elimination method is that it transforms the echelon form or even the original system into a reduced echelon form, into a reduced echelon form, okay? So what is the reduced echelon form? In the reduced echelon form, in addition to the echelon form, there will be zeros above the leading term as well. So for example, in the echelon form, there will be a 0 below this leading form and below this leading form, and then there will be a 0 over here, okay? And of course, 0 was there already over here. But in the reduced echelon form, there will be a 0 over here as well, over the leading term. So in the echelon form, there are zeros below the leading term. Whereas in the reduced echelon form, there are zeros in addition to the echelon form, there are zeros above the leading terms as well. So this is the difference. So we will see that how this method works out. And then there is a concept of augmented matrix, okay? Concept of augmented matrix. So what is an augmented matrix? Augmented matrix is nothing but the representation of the system of linear equations in the form of just numbers. So for example, if we have an equation, something like a11x1, like a11x1 plus a12 x2 plus a13 x3, okay, is equal to b1, okay? And then similarly, we have these terms, okay? So instead of writing these equations with all those x and b x values, we can simply write this type of equation in the form of a matrix. So for example, a11, a12, a13, a21, a22, a23, a31, a32, a33, and then we can have a vertical line, and then we can write those right side coefficients b1, b2, and b3. If we write in this form, this equation, and this will be the matrix form, but we will call that the augmented matrix because we are taking these terms of these b1, b2, b3 terms also with that. So this will be the augmented matrix. So this form is only for the convenience, because in the end, the solution of the equation will depend on these coefficients. Okay, so we can manipulate these coefficients with the row operations, and then it will be easier to work with those coefficients. So that is called as the augmented matrix. So in the augmented matrix, usually we place a vertical line to separate the left from the right side of the equations. Okay. So this is the brief summary of the theory for the topics today. So I can solve some of the examples to illustrate the method. Okay. Any questions?
Yes. So, in the later lectures, will we cover the other methods of solving the linear system of equations, like Cramer's rule and other ways where a determinant is involved?
Yes, for the determinant, there will be a separate topic later on.
Okay, thank you.
Yes. And of course, there are other methods as well, finding the inverse of the matrix or like that. So let's take the one example. Okay, so for example, if you have a system of equations, for example, like this example, 7x1 plus 3x2 is equal to 6. 11x1 plus 5x2 is equal to 12. So this is a simple two variable equation. So if we want to solve this equation using the Gauss elimination method, so we will set up its augmented matrix first. So augmented matrix will be 7, 3, 11, 5, and then 6, 12. Okay, so this will be. So now we will apply the row operations on this augmented matrix. So for the application of the row operations on this augmented matrix, so we can see that there is 7 and then there is 11 over here. So we want to transform this matrix 7, 3, 11, 5 into the echelon form. So in the echelon form, the first row is will have the first non-zero term. So this first row already have a non-zero term. So this means that we don't have to change the first row. But in the second row, we have now, if we transform it in the echelon form, in the second row, this term where 11 is here, it should be 0. So to make this 11 as 0, what we will do is we will take their common multiple. So for example, we can multiply this the second equation by 7, and then it will be it will become 77. So we will take a row operation which will be called as the 11 times R2, and then that will be the new R2. Okay, 11 times R2. So this augmented matrix will be equal to 7, 3, 6, and then we multiply it by 7, 11, no, sorry, 11, 7, yeah, sorry. So we multiply a second row by 7, and then that will be the new second row. So it will be 77, 35, and 12 sevens are 84. Okay, so this will be the equivalent matrix. So now in the next step, now what we can do is we can multiply this first row by 77 and then add it to the second row to eliminate this 77. So the next row operation will be multiply by actually not 11 but minus 11. Okay, so minus 11 times the first row. Okay, and then add it to the second row, and then that will be the new second row. Okay, so so now we need to do some rough calculations. So minus 11 times 7 is minus 77. and minus 11 times 3 is minus 33. Okay, and minus 11 times 6 is minus 66. And then if we add it to the 77, 35, 84, so what we will get? We will get 0, we will get 2, we will get, what will we get? 84 minus 66 is?
18.
18, okay. So the new matrix we will get now is, so therefore, first row will not change. So 7, 3, 6, and the new matrix over here we will get is 0, 2, and 18. Okay. So now this is the echelon form. So you can see that the first non-zero term is 7 over here, and in the next one, the first non-zero term is 2 over here. So this is the echelon form. So in this echelon form, now we can transform it back into 7x1 plus 3x2 is equal to 6, and then 2x2 is equal to 18. So now we can apply the back substitution method, method. Okay, back substitution method to determine the value. So for the back substitution, now we can, from here we can find x2 will be equal to 18 divided by 2, that is equal to 9. And then we can back substitute x2 into this. So 7x1 plus 3 into 9 is equal to 6. So 7x1 will be equal to 6 minus 27, that is 6 minus 27 is minus
21.
Minus 21, right? Yeah, it will be minus 21, and then x1 will be equal to minus 3. So the solution will be, solution is x1, x2, so is equal to minus 3 and 2. So this is the, sorry, minus 3 and 9.
9.
Yeah, minus 3 and 9. This is the solution. Okay, so in this case, you can see that although this is a simple example, you could have solved it by some other more convenient methods. But the systematic way for solving this example by the Gauss elimination method is like this. Okay, so let's try another example, this time a 3 by 3 equation. Okay. So let me do it on a fresh sheet. Example with 3 by 3 method. X1 plus sorry, 2x2, if the equation is x1 plus 2x2 minus x3 is equal to minus 3, and then 3x1 minus 3x3 is equal to minus 15, and 7x1 plus 15x2 plus x3 is equal to 4. So the first step is write the augmented matrix. So augmented matrix is 1, 2, minus 1, minus 3. So you can draw a vertical line to separate the left and right side of the equations. And then it will be 3, minus 3, minus 15. And then it will be 7, 15, and 1. Here, here it is minus 3 is x3, so it should be not here, it should be here. So I should correct it. So, but in this place, it should be a 0 over here. It should be a 0 because in this second equation, there is no x2, so there should be 0, and then it will be minus 3. Minus 3, and then the last one, it is 4. So now our goal is to transform this augmented matrix into the echelon form. So in order to transform into echelon form, so the first pivot position is over here, 1. This is the one term. So therefore, these both 3 and 7 should be zeros. Okay. So so therefore, I will apply the row operation. So minus 3 times the row 1 plus row 2. So that will be the new row 2. Okay. So I will apply this operation. Minus 3 times row 1 is minus 3 minus 6, and then plus 3, and then plus 9. And then it will be 3, 0, minus 3, and minus 15. So then I will get 0, minus 6, and then 0, and then minus 6. Okay. And the second row, this is actually the rough work. Okay. So that you can put aside. So because in the end, this 0, minus 6, 0, minus 6 will be the will go into here. And here you have 7. So in this, here it is 1, here it is 7. So what will be the row operation that will be applied? Minus 7 times row 1 plus row 3. That will be the new row 3. Okay. So minus 7 row 1 will be minus 7 minus 14, and then 7, and then 21, and then it is plus row 3. So it is 7, 15, then it is 1, and then it is 4. So it is 0, and then it is 1, and then it is 8, and then it is 25. Okay, 0, 1, 8, 25. So this is the new row. Okay, so now I have now transformed it into I don't know whether I have transformed it or not. So let me write it first. So it will be 1, 2, minus 1. So first row is not going to change because it was already in the correct form. The second row, 3, 0, minus 3 will change into 0, minus 6, 0, minus 6. Okay, 0, minus 6, 0, minus 6. So 0, minus 6, 0, minus 6. Okay, and the third row is third will change into 0, 1, yeah, 0, 1, 8, 25. 0, 1, 8, 25. 0, 1. So it is 25 or 24? Yeah, it is 25. Okay, 0, 1, 8, and then 25. Right? So it is this one. So now, is this an echelon form?
Not yet.
Yeah, it's not yet because in this case, this is the first column and then this is the second column, but this first leading term over here, that should be in the echelon form. So in order to make it more into the echelon form, so we need to make this one as 0. So what row operation I will choose? I will choose, what I will choose is I will take 1/6. Okay, I will take 1/6 of row 2, and then I will add it to row 3. So that will be the new row 3. Okay, I will take 1/6 because if I take 1/6, then it will become -1, and then -1 plus 1, that will be the 0. So in this case, now that it will transform into 1, 2, -1, and then it will be -3, and then it will be 0, minus 6, 0, minus 6. Remember that we don't need to change this row 2, okay? Although we can even do that, but we don't need to do it here because we can see that 6 is a common. So what we can do as an additional step, we can just divide it by -6. So it will make it more simple, but really it is not needed over here. So we just go ahead and try to make this into the echelon form. So now it will be, so for example, if I divide it by -6, this row by 1/6, so what will be the arithmetic over here? So 0 will be 0, and divided by 6, so it will be -1, 0 will be 0, and then -6 divided by 6 is -1. And then third row will be 0, 1, 8, and then 25. So what it will be? So it will be 0, 0, and then it will be 8, and then it will be 24. So this third row will be 0, 0, 8, 24. And then that's it. So this is also a like a scratch arithmetic. Okay. So now you can see that this is in echelon form. Okay. So for example, there are more in this main matrix. We can see that this is in the echelon form. So we can do the back substitution. So 8. So it will be in the equation format. So in the equation format, so we can write it like this now. X1 plus 2x2 minus x3 is equal to -3. So this is the same as the original equation. The second equation is now it is -6x2 is equal to -6. And the third equation is 8x3 is equal to 24. So from the third equation, we get x3 is equal to 24 by 8, that is 3. And from the second equation, we get x2 is equal to -6 by 6 is equal to, by -6, that is equal to 1. And from the first equation, we get now x1 plus 2 into 1, x2 was 1, and -3, minus x3 was 3, is equal to -3. So now we get x1 is equal to -2. So in the end, we get answers as x1 is equal to -2, x2 is equal to 1, and x3 is equal to 3. Okay, so this was the Gauss-Jordan, Gauss elimination method. Okay, this was the Gauss elimination method. Okay, so yeah, in this case, we have used the Gauss-Jordan Gauss method for the solution of the equations. Okay, so little exercise whether the following are echelon forms or not. Echelon form or not. So for example, if I say that if this equation is in echelon form, if I say 1, 0, 0, -1, 0, 1, 0, -3, and 0, 0, 1, 0. Is this equation in echelon form?
Yes.
Yeah, this equation is in echelon form. So for example, over here, 1 is the leading term, and the next leading term is towards right over here, and the next leading term is also towards the right here. So this is an echelon form. How about this? 0, 3, -1, 0, 1, 0, 0, 4, 0, 1, 3, 1. Is this in the echelon form?
No.
Yeah, because in the first leading term over here is 3, okay? And the leading term in the next equation should be towards the right of 3, okay? But here it is to the left of 3. So if you want to make it into the echelon form, we need to interchange these two terms. And then we can do, but of course we will not, we don't want now. So So we will just simply say that it is not in the echelon form. Okay, how about this? 1 minus 1, 0, 4, and then I have 0, 1, 2, minus 1, 1, 2, minus 1, and then I have 0, 0, 1, 5, and then I have two rows of zeros, 0, 0, 0, 0, 0, 0, 0, 0. Is this echelon form?
Yes.
Yeah. So according to the definition of the echelon form, the zero rows can be, 0 rows are allowed, but the condition is that 0 rows should be towards the end of the, and in the ending rows, okay? And here, yeah, 1, 1, 1. So leading term is moving in the stepwise direction. So this is the echelon form. Okay, so we have done the Gauss elimination method. Then probably we can now do another example for the Gauss-Jordan elimination method. Okay, so in the Gauss-Jordan elimination method. Okay, so examples. Okay. Method is Gauss-Jordan elimination method. Okay, so again, we try with the 2 by 2 two equations. So 5x1 plus 3x2 and minus 3x1 minus 2x2 is equal to 1 and is equal to 4. So Gauss-Jordan elimination method, actually for that, what we need to do is we first need to write the augmented matrix. So 5, 3, minus 3, minus 2, and then 1, 4. In the Gauss-Jordan elimination method, actually this method first transforms the augmented matrix into the echelon form and then into the reduced echelon form. Okay, so first we will transform it into the echelon form. So for in this case, for 5 and minus 3, there is the common multiple of 15. So what we do is we can transform, we can multiply the second row by 5. So we take 5R2 and that will be the new second row. So 5, 3, and 1. First one will remain the same, and then we multiply it by 5, so it will be minus 15, and then it will be 10, and then it will be 20. So now the second row operation is we multiply the first row by 3.
I'm sorry.
Yes.
You forget the minus sign.
I forgot
The
minus sign. So
yes.
yeah, and then it should be minus, right? Yep. Okay, so it should be minus here. Okay. Yeah, so now we multiply the first row by 3 and then add it into the second row. So this will be the new second row, okay? So 3R1 will be 15, then and then it will be 9, and then it will be 3, and then it will be minus 15, minus 10, and 20. So then it will be now 0 minus 1 and then 23. 0 minus 1 and then 23. So the new 5, 3, 1, and then it will be 0 minus 1 and 23. So actually for Gauss elimination method, this is the step because this is already an echelon form. But in the Gauss-Jordan elimination method, there is an additional step. That additional step is that the Gauss-Jordan elimination method says that the leading, the terms above the leading coefficient should also be 0. So this means that this method will says that this 3 should be also 0. So for this to happen, what we will do is, so we will multiply this row 3, second row by 3. Okay, we will multiply the second row by 3 and then add it into the first row. So that will be our new first row. So in this case, how it will happen? So when we multiply it by 3, so it will be 0 minus 3 and then 69. 69, and then now we will add it to 5. Then it will be 3 and then it will be 1. So what we will get is we will get 5, 0 and 70. So the first row will become now 5, 0, 70, and the second row of course will remain the same, minus 1, and then it will be 23. Okay, so in this way, and then actually then there is one optional step you can also make, is that you can make all leading terms as equal to 1. Okay, all leading terms. So for example, the first leading term is 5, and then second leading term in the second row is 1. So we can also make all these leading terms as 1. So this we can also done. This is just optional, although may not be very necessary over here. So what we can do is, so we can divide first row by 1 by 5, the first row. So that will be our new first row. And then because this is one of the row operation, so this is not going to change anything. And also at the same time, we can divide, we can multiply by the second row by minus 1. Okay, and then that will be our new second row. So alternatively, we can also write it like this. So we can divide it by 5, so it will be 5. Then 5 divided by 5 will be 0. 0 divided by 5 is 0. And 70 divided by 5 is, what will we get?
14.
70 by 5, that will get
14.
14, yes, 14. And then 0, and then we multiply it by 1, so it will be 1, and then that will be minus 23. So now we can transform this system into the equation format. So it will be 1, that will be x1 is equal to 14. And then the second one is x2 is equal to minus 23. So here you can see that we actually have got answer directly. Okay, we have directly got the answer by this Gauss-Jordan elimination method. So this is the only difference between the Gauss elimination method and the Gauss-Jordan elimination method. Okay, so that is the the second method. Okay, maybe we can do one more example by the Gauss-Jordan elimination method. Okay, so suppose we have this equation. over here, 2x1 plus 3x2 minus x3 is equal to minus 2. 4x1 plus 5x2 minus 3x3 is equal to minus 2, and minus x1 plus 3x2 plus 5x3 is equal to minus 8. Okay, so its augmented matrix will be 2, 3, minus 1, minus 2, and 4, 5, minus 3, minus 2, and then minus 1, 3, 5, and minus 8. So this will be the augmented matrix: 2, 3, minus 1, 4, 5, minus 3, minus 1, 3, 5, minus 2, minus 2, minus 8. So now we need to perform the row operations. Actually, Gauss-Jordan elimination method prefers to have one in the prefers to have one in the pivot positions. So maybe in the very beginning we can do like this. So for example, this is one, you can do it later or you can do it within this method. This is up to your choice. So for this, this 2 should be 1. So in this case, then the row operation will be divide by 2. Okay, the first row divided by 2, and that will be the our new first row. Okay, and that will be our new first row. Yeah, but actually this maybe one more thing which you can do is that then yeah, I just have seen one thing is that because one of the row operation is that we can also interchange the rows. Okay, so what we can do is we can see that there is this minus 1 over here. Okay, there is this minus 1 over here, and we can why not we can interchange it over here, and then that will make it a little bit easier. Okay, so yeah, actually there is nothing wrong, Vicky. Maybe you can do 1 by 2 as well, but just the choice over here. But make sure that you mention the row operation. So what I can do is I can interchange the row 1 with row 3. Okay, so what is going to happen is, and then at the same time, I multiply the row 1 with row 3, so that will be the new row 1. So and then also multiply by row 1 by minus 1. So minus r will be the new row 1. So it will be 1 minus 3 minus 5 8, and then it will be 4 5 minus 3. So 4 5 minus 3 minus 2, and then it will be 2 3 minus 1 minus 2. So what I have done over here is, as you can see that I have exchanged these two rows, so it will become minus 1 minus 3 minus 5 and 8, and then 2 3 minus 1 minus 2 have come over here. So now what I can do is, now I can multiply the first row by minus 4, and then add it to the second row, and that will be the new second row. Okay, to make 4 as 0, and then this make 2 as 0. So what I can do is I can multiply this by 2 minus 2, and then add it on the third row, and then that will be the new third row. Okay, so it will be 1 minus 3 minus 5 and 8. So now it will be 4, so that will be 0. Okay, so this one I multiplied by 4, so it will be 12. 12 plus 5 is 17. Okay, check with this calculation, and then if tell me if I'm doing it right or I'm making a mistake. Okay, and then we multiply by 4, it will be 20. 20 minus 3 is 17. So this is also 17. Okay, and now what is this? 32. 32 minus 2 is 28.
It's minus 32.
So it will be minus
It's minus 32.
2 is so minus 34. Okay, so it will be minus 34, and then minus 2 plus 2 is 0, and then it will be 6 plus 3 is 9, and then it will be 10 minus 1 is 9, and then it will be 16 minus 2 is 14. Minus 16 minus 2 is minus, right? Yeah. So minus 16 minus 2 is 18. And this is the difficult part, these calculations. So here the computer works well in this case. Okay, so although we have now in this, so now what I want to do is I want to make this 17 as 1. Okay, so what I can do is I can divide by 1 by 17, row 2, and that will be the new row 2. Okay, so 1 minus 3 minus 5, 8, and then it will be 0, 1, 1 minus 2, and then it will be 0, and then maybe even to make it more convenient, so what I can also do is 1 by 9, row 3 will be the row 3 as well. So yeah, that makes sense. Okay, minus 2. Okay, so now I think we are not in the, we can see that the first, second row and the third row are exactly same. So this means that we are not getting any unique solution from here. So what will be our next step? So I can do is, I can take minus of the row 2 and then add it to row 3. Okay, and then add it to row 3, and then it will be new row 3. So it will be then 1 minus 3 minus 5, 8, and then it will be 0, 1, 1 minus 2, and then it will be 0, 0, 0, 0. So third row will be entirely 0. Okay, and that the 0 is equal to 0. So this means that we are not getting any unique solution over here. Okay, so but since we are applying the Gauss-Jordan elimination method, so we should have a 0 over here as well. Okay, so this 0 over here first. Okay, so what I will do is, so I will take 3 times the row 2. Okay, 3 times the row 2, and then I will add to row 1. So that will be the new row 1. Okay, so because this was 0, so it will not change. And then I took this 3 and then I added it, so it will be 0. And then I make it like 3 plus 3 minus 5 is minus 2, and then it will be minus 6 plus 8, minus 6 plus 8, it will be 2. So it will be 0, 1, 1 minus 2, and that is 0, 0, 0, 0. So is it in the reduced echelon form? Or we do anything, or do we have to do anything more? No? Yeah, this is now in the reduced echelon form, because all the last term was 0. So therefore, there is no pivot term. So therefore, we don't need to make them 0 over here. So this is already in the reduced echelon form. So now what we can do is we can write this equation into the, write this augmented matrix into the equation format. So x1 minus 2 x3 is equal to 2. Okay, x1 minus 2 x3 is equal to 2. And then here it is x2 plus x3 is equal to minus 2. And then the last term is 0 is equal to 0. So that doesn't make anything. So in this case, now we have 3 variables, but 2 equations. So therefore, one of the answers should be a free variable. So we choose x3 to be equal to 0, okay? Sorry, we choose x3 to be equal to some free variable s1. And then we calculate x2 will be equal to minus s1. And then in the first equation, yeah, so sorry, no. So x3 is equal to s1, and then x2 plus x3, that is s1, is equal to minus 2. So x2 will be equal to minus 2 minus s1. And then x1 will be equal to x1 minus 2 x3. X3 was s1 is equal to 2. So x1 will be in this case equal to 2 plus 2 s1. So the solution set will be 2 plus 2 s1 and minus 2 minus s1 and then s1. Okay, so this will be the solution set. Okay, this will be the solution set. Okay, so in this way, well, whether you get a unique solution or not unique solution, you are able to solve any system of the linear equations, okay, by the Gauss-Jordan method. Okay. So yeah, I think this is enough for these two methods, Gauss-Jordan and the Gauss elimination method. So this completes chapter 1 of the textbook. I am not covering the other topics like in these these are the optional topics. Okay, so I'm not covering those optional topics. And next in the next class we will start the chapter from chapter 2. Okay, do you have any question?
Can you please clarify what's the difference between echelon form and triangular form?
Yeah, in the echelon form, there is a you can include the zeros at the end. Okay, 0 rows in the end. Whereas in the triangular form, there is no zeros at the end. Okay, so in the triangular form, we will do more about the triangular form later on. Triangular form is mostly with the square matrices. Okay, so in those triangular form, there is no question of having zeros in the end. If there will be zeros, of course there can be, but that will be not a triangular form. So in the triangular form, all the zeros will be below the diagonals. But whereas in the echelon form, it also deals with the zeros in the end. That means the rectangular shape of the matrix as well. So that is the only difference.
Okay, good.
Yeah. Okay. Okay, so